There are some significant changes in Formula One next year as we move into the 2014 season. In fact, some of the biggest changes that Formula One has experienced since its inception in the 50s, all towards energy efficiency and energy recovery.
Next year we'll have a very big change in the regulation from a 2.4-litre naturally aspirated engine V8 to a 1.6-litre turbocharged engine with a much bigger cars, around 160 horsepower, that will be able to push the car for up to 30 seconds if you have energy in your battery.
Today a car system gives an advantage of 3 to 4 tenths per lap. Will be close to the 3 seconds per lap next season, so it's really 10 times more powerful. There will be 2 electrical motors instead of 1, fitted and mechanically linked to the turbine of the engine. The turbine which is moved by the exhausts of the engine itself. So what will happen is that we'll use all the energy of the exhausts for the turbine to compress the air of the engine, but as well try to generate electrical power through an electrical motor which will charge the batteries.
This is a completely different way of handling the engine, because you have to recover energy if you want to be faster.
There's a couple of areas where Shell can contribute to performance for the air system. Firstly is we supply the cooling fluid for the battery, and it's vital that parts of the system are cooled sufficiently, and we only have to put in a small amount of cooling fluid because every additional milliliter of fluid that we put onto the car is weight.
Shell is our partner since many years, and we are collaborating very well with them, and the fuel is becoming really very important for the performance of the engine.
Alongside all the massive changes around the engine hardware for 2014, there's the limitation on fuel payload, so only 100 kilograms will be allowed to be fueled in the cars for the whole race.
So it means that here the objective will be to reduce more than 30% fuel consumption compared to what we are doing today.
On top of that, there's a fuel flow rate restriction as well, which puts a massive demand on fuel economy and how much energy the driver will have at his disposal for the whole race. So that adds an additional dimension to the development work for the fuels for the V6 engine, because alongside optimising for power, there's a real strong requirement for efficiency as well.
The lubricant can help improve the power and efficiency of the engine by reducing the losses inside it. Wherever the lubricant is protecting and keeping surfaces apart, the more you reduce that friction, the more power is left from the fuel to get out the wheels and to make you go faster.
Reliability is playing a key role. Each driver will have only 5 power units for the complete season, making engine life almost double what we are doing right now.
If you did lose an engine before the end of its life, the impact on the total season for the driver is much more severe, so therefore reliability and protection of the engine is much more important.
It should be fascinating to see how the new regulations affect how the drivers manage the energy flows from the turbo into the battery pack and then to the motor to power it. It will be a big challenge for the drivers.